Our solar system is an intriguing collection of planets and celestial bodies connected by gravitational force, with the Sun as its core. Within this vast system, we find a variety of celestial bodies, such as moons, dwarf planets, asteroids, meteoroi. Let's explore all of this and uncover the unique features of some of these planets, their captivating orbits, and understand how our solar system fits into the vast universe. Speaking of planets, our solar system is home to 8 of them: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The solar system has an impressive history of 4.568 billion years and is located in our galaxy, the Milky Way. Starting from Pluto's distant orbit, the solar system stretches over 5 billion kilometers. The nearest star system to the solar system is Alpha Centauri, located approximately 4.37 light-years away. Proxima Centauri is the closest star to our Sun, about 4.22 light-years away. Currently, our Sun is truly a giant. As to give you an idea, around 1 million Earths could fit inside it. Studies of its light show that this enormous star is largely composed of hydrogen and helium, with a small fraction of other elements. The Sun's core functions like a nuclear fusion reactor, constantly transforming hydrogen into helium, producing the light and heat it emits into space. Our star and the entire solar system likely originated about 4.6 billion years ago, when a cloud of matter came together. This matter may have come from explosions of ancient supernovae. Although the Sun is neither the largest nor the brightest star, it is fundamentally important for life on Earth. It is a medium-sized, stable, and relatively young star located in one of the spiral arms of the Milky Way. While its presence might seem modest in a galactic context, it is vital for life on our planet. Now, speaking of planets, they are divided into 2 categories: inner and outer planets. The inner planets are Mercury, Venus, Earth, and Mars, all rocky and smaller in size. The outer planets, like Jupiter, Saturn, Uranus, and Neptune, are gas giants that formed in regions farther from the Sun. This difference in density originates from the formation conditions in their respective areas. As we move farther from the Sun, temperatures drop, allowing various substances to develop. Closer to the Sun, only denser elements could condense, forming the rocky planets like Mercury, Venus, Mars, and Earth. In contrast, farther from the Sun, where temperatures were cooler, the formation was dominated by ice, leading to the creation of gas giants like Jupiter and Saturn. The separation between these 2 groups of planets is marked by the asteroid belt, where remnants of a planet that never formed due to Jupiter's gravitational influence are scattered. But what happened to Pluto? For a long time, Pluto was considered the 9th planet of our solar system, until in 2006, it was reclassified as a dwarf planet due to its orbital behavior. The main reason was that Pluto does not meet one of the criteria for being considered a planet. It does not clear its orbit, meaning it shares its space with other objects of similar size and gravity, such as its moon Charon. Now, this is just an introduction to our fascinating solar system. Each planet has its own unique characteristics that we will explore in detail. In this image, we can see the paths that the planets follow around the Sun. Now let's examine the main characteristics of some of these planets that make up our solar system, starting with Mercury. This is a small planet, about 1/3 the size of Earth, and it is the closest to the Sun. Observing its surface, we see rocky formations similar to those on the Moon, as shown in recorded images. One unique feature of Mercury is the lobate scarps, which suggest that the planet is shrinking over time. Additionally, Mercury shares some similarities with our Moon, including chemical composition, the presence of ice at the poles, and numerous impact craters. At certain times, we can see it from Earth, usually just after sunset or in the early morning hours. In terms of size, mass, and chemical composition, Venus is surprisingly similar to Earth. However, its dense atmosphere traps heat, creating a greenhouse effect that raises its surface temperature to over 400 degrees Celsius, close to the melting point of lead. Venus's atmosphere is predominantly composed of carbon dioxide, with traces of other gases, such as oxygen. The atmospheric pressure on Venus is about 90 times greater than that on Earth, and its wind patterns are extremely complex. A striking detail is Venus's rotation on its axis, which takes about 4 Earth days, although the planet itself rotates very slowly, with a Venusian day equaling 243 Earth days. Despite its thick atmosphere, Venus currently has very little water, though the high presence of deuterium suggests it may have harbored water in the distant past. The third planet from the Sun is our home Earth, the only one known to support life. Earth is at an ideal distance from the Sun, providing the necessary conditions for life to thrive. Additionally, it has a protective ozone layer, with large quantities of liquid water covering approximately 75% of its surface and a strong magnetic field. Unlike the other rocky planets, Earth has a relatively rapid rotation. Its atmosphere is composed mainly of nitrogen and oxygen, with smaller amounts of other gases. It is divided into layers that become less dense as we move away from the surface. A unique feature of Earth is the presence of tectonic plates, which cause continuous changes on its surface over geological eras. This means that traces of craters, common on other planets, have been erased. Earth features a variety of landscapes, including mountains, plains, and deserts, along with abundant water, both in oceans and as fresh water on the surface and in underground aquifers. The Moon, our natural satellite, influences Earth, particularly through tides, which play an important role in marine life. The Moon is tidally locked with Earth, always showing the same face. Mars. Now, let's focus on Mars, which is slightly smaller than Earth and Venus, but still larger than Mercury. Its surface has a reddish hue due to the high presence of iron oxides. For a long time, Mars has sparked interest among people, leading to speculations about the possible existence of intelligent life. Mars's atmosphere is thin and primarily composed of carbon dioxide, with traces of other elements like argon. There are no significant amounts of water vapor or oxygen. When present, oxygen is typically found in rock compounds. Mars does not have its own magnetic field, which allows particles from the solar wind to directly impact its surface, with little protection from its thin atmosphere. The Martian landscape is diverse, and there are signs that in the distant past, the planet had liquid water. One of the highlights is Olympus Mons, the largest volcano known in the solar system. It is 3 times taller than Mount Everest and has a volume 100 times larger than Mauna Loa, the largest volcano on Earth. Due to the absence of tectonic activity and low gravity, lava accumulated over time, forming this monumental structure. Jupiter. Now let's turn our attention to the giant of the solar system, Jupiter, undoubtedly the largest planet in terms of size. Its diameter is approximately 11 times greater than that of Earth, and its atmospheric conditions are extreme. Jupiter is known for its turbulent atmosphere, with strong winds sweeping across it. The notorious Great Red Spot is a long-lasting storm, with winds reaching up to 600 kilometers per hour. Jupiter is mostly gaseous, with no solid surface. However, as we go deeper into its atmosphere, the pressure increases, and the gas turns into a liquid. Its rapid rotation causes the planet to flatten at the poles. Although most of Jupiter is made up of hydrogen and helium, like the Sun, its interior contains a hot core of heavy elements. This is evidenced by the infrared radiation emitted by the planet, indicating high internal temperatures compared to its surface. Jupiter has its own magnetic field, about 14 times stronger than Earth's. Jupiter also stands out for having a large number of moons, including the 4 Galilean moons, Io, Europa, Callisto, and Ganymede, the latter being the largest moon in the solar system. These moons, with unique features such as water, volcanism, and extreme climates, are fascinating in their own right. Saturn is unmistakable due to its complex system of rings, first observed by Galileo in 1609. These rings are made up of millions of ice particles, possibly remnants of ancient moons and comets that collided with the planet. Some of Saturn's moons, known as shepherd moons, play an important role in maintaining the orbits of the rings and defining their regions in the planet's equatorial plane. Saturn has a distinctive shape, being an oblate spheroid due to its low density and rapid rotation. In fact, it is so light that it would float in a sufficiently large ocean. Its shape is also influenced by variable rotation depending on latitude and interactions with its moons. Saturn's internal structure is similar to that of Jupiter, with a gaseous mantle and a hot core of heavy elements. The Voyager, Cassini, and Ulysses missions provided data that support this conclusion. Today, we explored some of the planets that make up the solar system. May our quest for knowledge and exploration never end as we continue to unravel the mysteries, united by our thirst for understanding and passion for the unknown. Like and share the video. Subscribe to the channel and see you in the next video.